So by the way, nice beard there. I see you got a beard going.
Yeah. Seemed like the
Yeah,
thing to do these days.
This is my COVID-19 beard.
Yeah, that's what I was gonna say. Yeah.
As long as I'm working from home and I don't have to go into the office, I'm not shaving unless I have
to. Nice.
So man, Internet of Things. That's just for those that aren't aware of that term, and you all should be by now, I'm hoping. Internet of Things is just that. It's devices connected to a network that aren't necessarily standard computers, right? Not things
Correct.
that you would think of as computers.
Yes.
Right?
Yeah. Typically, there's a microprocessor in some way, shape, or form involved, but it's. I mean, it could be anything from thermostats to your vehicle. To something a little bit more sophisticated, which in additional complexity involved when it comes to talking to things like an assembly line, and think about barcode scanners and robots and industrial controllers. There's a whole nuance of things that you have to be nuanced about that you need to be able to plug in and extract data from those devices to be able to do interesting things, or anticipate whether or not you're going to have a machine breakdown, or alert somebody if there is a machine breakdown. Because all of these pieces of equipment have different protocols. They talk different languages. Sometimes some of them still today use serial cables. So we have some additional capabilities that you can actually put attached to something that might be old, that can make it appear to be new again when it comes to data collection and ingestion, using some capabilities we have that can run on any piece of computing hardware, whether it be a Raspberry Pi or a laptop or something a little bit more powerful than that. So
yeah. And I was just thinking about all of the Internet of Things devices that I have in my house, right? I mean, I've got a Ring doorbell, IoT.
Yeah.
I've got a Nest thermostat, that's IoT.
Right.
My security system has webcams, that's IoT. I've got a couple of Alexa devices, that's IoT. I've got Cortana devices, that's IoT. A buddy of mine just bought a LG refrigerator. That's certainly IoT.
Yeah. They can now. IoT isn't just involved in consumer devices, but think about power plants, utility generation, gas distribution lines. These environments that are large in scale and scope. The utility grid in a particular any additional or particular municipality would be massive, and it would be cost prohibitive to put an i5 based laptop or computing device every spot that there's a gas valve or a switching station. So it's common for these, or for utility companies to use these low power devices to capture data. Maybe you just periodically wake up and send some information. Likewise, you see it being used pretty heavily today in the smart building space, where in today's climate we have a lot of commercial buildings unoccupied, and think about lighting and HVAC, control systems to be able to try to reduce the not just the carbon footprint, but the energy usage for financial reasons of commercial buildings and in real estate. So used everywhere. I work with a lot of customers in the industrial front, and then also I have some customers that use IoT devices, particularly what we're talking about today in the edge space, actually on very large pieces of equipment. So think, dump trucks with tires taller than you. So these types, these customers are actually putting IoT edge devices underneath the seat of these vehicles to be able to capture telemetry from the vehicle, warn the driver if they're doing something that could damage it or cause harm to a multi-million-dollar piece of equipment, and then also helping the owners of these pieces of equipment be able to optimize the efficiency of it, because they're expensive, their downtime's expensive. So it's a good application for IoT stuff to be able to help, a real world application of IoT stuff to be able to help a customer save money ultimately.
Yeah, I think we'll quickly get to the point where there are more IoT devices on the internet than there are computers. We might already be there.
Yeah. I mean, it'd be interesting to see some counts on that, but I bet you're right. In fact, I wonder if that's to a large degree why they're, that IPv4, I'm just thinking about all the IP addresses getting gobbled up. I have to imagine that that's not helping.
Yeah, but that is certainly an issue that IPv6 solves.
Right. Yeah.
Yeah.
Exactly. All right. So let's dive in a little bit.
Stuff to show us.
Yeah. So let me go ahead and share my screen here. I got a couple of slides. I know slides are boring, but they do illustrate some points and some spots that are some things we can talk to before we kind of dive in and show.
I love your slides. I don't think How many Internet of Things devices are there on the Millennium Falcon?
I don't know. I've got quite a few phasers. Those are all IoT based.
The entire weapon system.
Yeah, pretty much. All right, so there are a couple different ways that we talked about smaller devices like thermostats and Ring cameras, and those are I don't want to say they're unintelligent, but they have low power, inexpensive compute microprocessors in them, so they can be sold to the likes of you and I at low price points. But there's not a whole lot of capability embedded in them to be able to do processing. So they tend to send data up to some place, typically some cloud provider, to be able to allow you to control them. So like my thermostat, I can pull up an app on my phone, see what the temperature is, and remotely control it or toggle it. And the message flow goes from my phone to the cloud and then down to the thermostat. So that solves a couple of challenges, and we talked about the IPv4 challenges. So it allows those devices to be installed behind network address translation devices, and so it kind of solves some security challenges and some technical challenges using that mechanism. But that doesn't work terribly well is when you think about a mine site in the middle of nowhere with pieces of equipment running around on it that need to have some the similar types of intelligence running on them to be able to inform the operator about things or make the vehicle do things, or in a automotive plant or a parts plant or widget plant, that has some pretty strict security guidelines on what can access the network. That very expensive and dangerous, potentially life-threatening pieces of equipment, with robots swinging around in the cell, you don't want them to come back online when an operator or maintenance personnel is in there. So that's where we here at Microsoft have taken some steps to take a lot of capabilities that we have in the cloud onto what we call the intelligent edge. And the intelligent edge is really comprised of a number of different services that can be deployed on compute devices. And I'm using the word compute devices generically because we have a lot of options here, including a Raspberry Pi. I've got a number of them on my desk sitting next to me that all have IoT Edge running on them, or it could be really high-end i-series machine, or one something an Intel-based machine, AMD-based machine, or something with a GPU to be able to do video processing. So it's kind of spans the spectrum on what type of compute devices is supported on, and we make this service, this capability available to customers largely free of charge. There's some components that are chargeable, but it is dependent on services we have in the cloud. So we allow you to extend that and run either in a disconnected state or in a state where you need to make decisions really quickly with pieces of equipment that are physically attached to you without having to rely on internet connectivity or some utility contractor that digs up a cable and shuts your plant down. So Edge really solves a lot of problems and challenges that kind of come into play when you start thinking IoT in non-traditional senses. So how does IoT Edge solve some of these problems? Well, what it comprises of is what we call the IoT Edge Runtime that gets installed or deployed on any of these compute devices. Whether it's ARM-based, or whether it's an Intel-based, Intel AMD-based machine. you install this runtime component onto the machine. You know, it could be Windows or Linux based. And what it provides you is the ability to take data from devices that might be physically attached to it. You know, in the case of pieces of equipment I was talking about earlier, there's a CAN bus that's inside of the vehicle that's specialized in vehicle network that we can actually pull data from. There's an Ethernet in the vehicle we can pull data from. In the case of a manufacturing plant, it might be robots or programmable logic controllers who we want to pull data from to actually run an assembly line. So we can actually pull that telemetry and process it locally on the edge. So typically, in that data flow we talked about, like with a thermostat, we have data sent from a thermostat up to the cloud. Some decision is made, and then whether it's you on your way home wanting to reduce your temperature in the summertime to make it cool when you get home. So the idea is that you can actually take all of those instructions and actually put them on a compute device inside of a plant or inside of a piece of equipment without requiring any dependency on the internet connectivity. So we have a service in Azure called IoT Hub. So devices can actually talk directly to IoT Hub. So, and in fact, actually, we have customers who are doing this. We have intelligent devices like thermostats that can talk directly to IoT Hub from within your home. So this is actually decoupling that and allow you to run it locally. So the IoT Edge runtime actually allows you to manage what actually is running on that edge also remotely, which is a really powerful story. Because when you think about, typically when you have some bit of functionality that might be processing data from a robot, let's say running in a plant, it's actually, now once you had deployed the solution, it becomes a challenge to go and touch maybe potentially 1,000 different IoT Edge devices that are physically attached to robots to update what the software is doing. So the IoT Edge runtime also allows you to remotely manage it and what the functionality is that's running locally from the hub. And we'll see that a little bit when I show a demo.
Okay.
So this will be my last slide, and I'll let this kind of build out because it's a kind of a complicated slide, but this shows what the IoT Edge really is. And if we've talked about containers in the past, on other shows, and I think you've had others kind of talking about what that, what that concept is. Container is a way to encapsulate and easily transport bits of logic, whether it be an application, or a machine learning module that maybe you train a machine learning job in the cloud and you want it to run locally where the data is actually flowing in. So IoT Edge allows you to remotely manage the individual services that are running on the edge, and those services are deployed as containers. So the Edge runtime, the IoT Edge platform, actually is in itself a container, and we'll see that when I actually connect to my Edge device. So there's a lot of security capabilities that I'm kind of glossing over a bit on kind of how that IoT Edge device authenticates to the cloud. There's a lot of complexity and options there to be able to say, hey, I'm really an IoT Edge device for, customer X manufacturing widgets, so that attestation is something that we have some complexity to be able to make sure, or complexity purposefully in a plethora of options to make sure that device is for the customer that it's intended.
Yeah.
And so from the IoT Hub, this is the cloud piece. There is a concept of a device twin, which is kind of a digital representation of the IoT Edge, like what its current state is, the last time it checked in, as well as a module twin. And what a module twin is a digital representation of these containers that are actually running down on the edge. So you can actually see, maybe if you had a container that was connecting to a local database that was running on the edge, maybe a local SQL server. So you can actually control connection strings up in the cloud, and it will actually get sucked down and presented to the module that's actually running on the edge. So the benefit of all of this plumbing is that you can actually deploy stuff which is up here on the right, down to the edge and have it run irrespective of what's happening with your internet connectivity or links to the cloud. So including things like our AI services. So we have, Azure Machine Learning, Azure Stream Analytics, Azure Functions. These are capabilities that run, in the Azure platform that you can actually, run locally on the edge. And then you can also build your own applications and run them and deploy them as a container that do other specialized things. Some of my industrial equipment customers might have a module that it knows how to talk to a particular piece of industrial equipment that they purchased. So you can actually control and manage that all from IoT Hub. So let's look at what that actually looks like.
So would you consider the Mars rovers IoT devices?
Yeah. Actually, that might actually be more akin to an IoT edge device, because you send it a bunch of instructions, they get queued, and it just does this thing and then phones back.
Yeah. So that would mean that we have IoT devices in interstellar space. Because of Voyager, they communicate with Voyager.
Yeah, heck, that goes way back. That's in the 1970s.
Yeah, there you go.
All right, so I will make this a little bigger. Kind of increase it a little too fast here. Okay, so I'm in a IoT hub. This is actually a hub that I've deployed in my subscription, and the hub can actually, as I mentioned earlier, can actually have devices that connect directly to the hub. Things like thermostats or Ring doorbells would be example. So it can actually have devices that connect directly to the hub. And IoT Hub is a core service in Azure that basically facilitates massive numbers of devices communicating and sending data. But it also supports edge devices being connected to it. So I have this OPC test device, and you can see it's showing me how many modules. These are containers that are actually running on that device. And it shows how many clients are connected to that. So there's this is actually because of that twin that I talked about, that digital representation. So there's updates that are being sent because my edge is actually able to talk to the cloud, and that internet link is up all the time because it's running on a virtual machine that I have up, also hosted in Azure. That data is fairly real time. So when I drill into this, so these are the modules that are actually running on my IoT Edge device. And there's two of them that are actually the IoT Edge itself, and they have a $sign in front of them, Edge Agent and Edge Hub. So when I go to, let me just go ahead and pretend I'm going to change one of these. And if I go to this runtime settings, so in here, this is actually telling me that there's two core containers or images, container images that are used to actually represent the IoT Edge runtime. So I've installed IoT Edge runtime on this VM, but now we can actually centrally manage the version of the container of the version of IoT Edge just running on this VM, simply by going to the IoT Hub and saying I want to run, instead of version 1.0.10, and I'm running a release candidate, maybe release candidate 3 comes out. So I can go in here and literally update this, and this will send an instruction down to my edge that'll actually tell it to go out to this container registry and download a new version. So this is where some really powerful capabilities comes into play to be able to manage not just the edge runtime itself, but maybe code that you've perhaps written yourself to be able to do interesting things with a robot or piece of equipment. You can actually manage that at scale. Now, I say at scale because I want to emphasize that, because right now I'm just doing it individually. I've drilled into a very specific device, and I'm telling it I want to change a version that's actually running on that device. So you can actually do this in bulk, saying I want to change all of my edge devices, or maybe all of my edge devices that are in Europe, but to run this particular module, or update of IoT Edge. So you have some pretty great levels of sophistication here to control that. And I've got a lot of parameters that I'm passing into that I will kind of gloss over for the moment. But what I really want to show is these three containers that I have running, and this is actually part of our IoT Edge connected factory capability that we have, that some industrial some abilities for you to be able to easily connect up to industrial devices. So if I want to flip back to my slide deck that I think I just closed, but I had one more important slide to show, and it talks a little bit about what this OPC letters mean. And OPC stands for OLE for process control. It actually goes down to the.
I thought it was other people's containers.
Yeah, that would actually be really appropriate if it were called that. So this is actually much like a container, though. It is an open standard, and there are lots of, actually I should even go as far to say all industrial equipment companies have devices that can talk in a manner to be able to interface with OPC software. So, and it kind of goes, this is a triangle kind of showing, where you have, the most number of devices, sensors, motors, actuators, and so forth. Those usually talk over proprietary industrial networks. And this is where it gets really hard to take something that's been running in a plant for maybe 20 years that's producing widgets and be able to enable it to send data up to the cloud to be able to take advantage of machine learning and try to, predictive maintenance and, predictive failure type capabilities that exist in the cloud. Because these protocols are old, but they're still heavily used and widely used in the industrial space. So the only way to be able to interface with those is to have something like an edge device is physically sitting in the plant and has the capability to talk, some of those protocols. And then, kind of going up the stack, usually you have something called a programmable logic controller. And this is it's kind of a small industrial computer of sorts that has physical wires getting, connected to it to be able to control, what happens when an operator hits a start button on a piece of equipment at a station. So you kind of have this stack of stuff, sensors, the PLCs that can actually talk to those sensors over those industrial networks, and then there's this long-standing set of interfaces that customers have been using for decades, OPC Classic and OPC UA, which are ways to be able to connect to these programmable logic controllers with software. And by software, I mean, these programmable logic controllers are pieces of hardware, very specialized pieces of hardware. They don't have screens on them. They just run the same task over and over again to be able to control, manufacturing lines typically, or industrial applications. So to be able to get data from them, you need to have some piece of software running on a computer, a PC. In the way that computer can talk to those programmable logic controllers at companies like Siemens, Rockwell, Allen Bradley, General Electric, all these companies that make programmable logic controllers allow their PLCs to talk to this OPC language, for lack of a better description. And this is a slide from the OPC Foundation kind of showing where these different OPC communication mechanisms exist. So why this is all interesting and important is I have a fake factory that I put together, and this is a Windows server. It's not producing widgets or anything exciting, but I have an OPC simulator running on it. So this is actually simulating data that might be getting pulled from one of those programmable logic controllers that might be running a robot, or that might be running a manufacturing cell in a plant. So what I've got a couple different simulated signals that are being sent from this, such as a sawtooth signal. See that this is actually just creating a value that, that ramps up and goes back down. So I have a bunch of random data that's actually being sent from this factory, and these would be indicative of, you know, maybe a pressure sensor from one of those programmable logic controllers, or you know, in the case of like a counter, you know, like
a 1 and a 0 over and over again.
Yeah, exactly. Yeah, yeah. And you know, the counter is just kind of is counting up to 100 and going back down to 0. So these are just simulated signals that would be, you know, you know, on a programmable logic controller, there'd be a card in a rack that would have a bunch of wire terminals for outputs to be able to fire a solenoid or something like that. So these could be representative of values coming from those cards, you know, the analog and digital signals. So I have this running on this VM, and I have the OPC, or the IoT Edge device I just showed you. And I showed that IoT Edge device is actually running a couple of modules, and these modules are containers. If I go like this OPC publisher, this is actually coming from the Microsoft Container Registry. It's one that we produce, and you can see it's in the IoT Edge repository, and it's called OPC Publisher. And I'm getting the latest version of it. So this is actually the vehicle that I can actually use to be able to talk to my fake factory. So what I have here, and actually one other little piece of information. So the when you create a container in Docker or in Kubernetes, there's a whole bunch of options you have that you can feed to that container, such as you know, details about how it interfaces with the network and the machine that it's running on, or details about how it interfaces with storage on the machine that it's running on. And storage is actually a pretty particular important one, because containers, they are ephemeral. And by that I mean, like, if this OPC publisher container crashes, if there's a you know, segmentation fault in the software in this container, the IoT Edge runtime will detect that, and they'll just create a new version or new instance of it. So it'll keep it running for me automatically. So it's all managed by the IoT Edge runtime. In the Kubernetes world, Kubernetes does the same sort of thing. So the drawback with that is obviously if you're storing data, things like config files or log files, or you know, things of that nature, or data files. If it's like a Mongo database that has that stores its data into files, it needs to be able to persist that data somewhere. So when it gets started back up again or power cycled, that data is still there when that container fires up. IoT Edge modules work no differently than Docker or Kubernetes or Mesosphere, any of those environments. So what I have here is I'm actually telling it to mount this industrial IoT Edge folder to a folder called app data inside of my container. So this is how I can so I'm basically taking something from my local file system running on my edge, and I'm exposing it into the container. And particularly what I'm actually exposing it to, or the reason I'm doing this, is there's a config file in here that I actually have details of what data I want to capture from my fake factory. So, and it's getting it from this config file. So this is kind of the glue to slowly stitch things all together. So if I go here, this is actually, this is my Edge device. I have it running on Linux. And if I do Docker PS, this will show me all of the containers that are running on this machine. And if you remember when I showed you the IoT Edge runtime, there's a 1.010 RC2. That's the Edge runtime that's running on here. And that's also the agent runtime that's on here. So these are the two pieces that are IoT Edge itself. And the other three are the three that you see here: Discovery, OPC Win, and OPC Publisher. These are ones that we make available for customers to use to easily talk and interface these industrial protocols. So, and then if I go into this folder, if you remember in the configuration, I told it I want to take the IoT Edge folder and surface it to my container. And if I look at this file, you can see that I'm actually connecting to my IoT junk box, which is my fake factory. So this is actually this is the port that's used by OPC UA. And I'm specifically telling it I want to take data from the counter and the sawtooth. So these are you can see right here the counter and sawtooth, and I'm sampling them at a rate of in every 2 seconds. It's actually getting data from that particular tag. It's called an OPC world. So the way it works is you have a PLC that might have thousands of wires going to different racks that are deployed in electrical panels around a plant, and you attach an OPC server to that programmable logic controller, and then you create tags that are actually watching data in that PLC that surfaces it to things like displays in the maintenance crib to maintenance supervisors about the health of the pieces of equipment. Or in this case, I'm actually vacuuming up that data with this edge device that I'm actually taking these tags that are exposed from my fake factory and sending it up to the cloud. So where this kind of comes full circle and comes back together is I have if I could just type correctly. So I have data coming in. Actually, just to prove that data is coming in, if I go back to my hub, I don't have any other devices that are connected to this IoT hub. And you can see the message count, because I fired it up earlier today around lunchtime, has been slowly climbing. So I've been getting, every 2 seconds, I get a message. Actually, I get 2 messages. So I've been getting a lot of messages coming from my fake factory that's actually been sampling those messages, and you can see that I only have the one connected device to this hub. So now I have my edge configured. It's pulling data from my fake factory. Now I want to do something with it, and to kind of pull it all together, the final piece of the puzzle. There's a service in Azure called Time Series Insights. So this is a easy to use service that allows you to see time series data. So what is time series data? That would be data that's trending or changing over time to kind of visualize in a visual manner, or be able to trigger alerts or alarms if some state or threshold is actually exceeded. So it's got some capabilities to kind of establish some trend lines and determine what's normal and alert you if things deviate past normal. So there's some capabilities in there that allow you to set that all up. But what I'm going to use it for is to show you the data coming in. And while that's loading, I can see some other interesting stats of that you can see it's very close to real time. That I have a couple spikes where it jumped up to this is the ingress lag. The time it takes for data to come out of my hub into my time series database is a second or less. So it's pretty darn close to real time, as long as that edge device is connected. So what were to happen if my edge device were disconnected? Well, that's another really cool feature of IoT Edge, is that with all these services running on that IoT Edge device, IoT Edge will actually store that data locally on that machine until service is restored or the connectivity is restored, and it will upload all of that data to my hub and let me do things with it later. So, right now I'm doing stuff with it fairly real time, but it can work in a disconnected state. So I'm just going to zoom in to a particular period of time here.
And to be clear, you could do anything you wanted with that data, right? You could populate a dashboard with it. You could send it to Excel. You could do whatever you wanted.
Yep, exactly. Yeah. Yep. So you can see here's my sawtooth data that I'm actually graphing out here. So this is actually showing the data coming in. I mean, this isn't super interesting and compelling, but what it demonstrates is something that I worked in the controls automation space for probably a better part of a decade, doing a lot of industrial automation related projects for customers, primarily in automotive and kind of vehicle space. And this is actually a really challenging. We charge six-figure contracts for building applications that would interface with pieces of equipment and surface data like this to customers. I mean, this is going back, 20 or so years ago, but this is showing very quickly that I can take an edge device, configure an IoT hub, and modify that config file to point it to an OPC server. Then any industrial customer is going to have that sitting in their plant, usually in some way, shape, or form, if they're getting data from it for maintenance purposes or statistical purposes. And we can tap into that data stream and do interesting things with it. Whether in this case, the interesting thing is just showing it on a graph, but it could actually be much more sophisticated, like feeding this to a machine learning model. That might actually give me some some indication that the machine is having some abnormalities at certain points of the day, or maybe create some relationship between that and temperature or the operator using the machine. So it allows you to make some very powerful correlations with that data that might be hard to do with just looking at that data raw. So, and you can do so very quickly, and this is also not a very expensive thing for a customer to do. And I think an IoT hub is less than $100 a month. Time series insights, and I'm running in a consumption mode, which means I only pay for what I'm using. So just say a couple $100 a month, and you'd be able to have a solution like this, tapping into data coming in from a factory.
Wow, that's really cool.
Yeah.
And there are so many uses for this, right? I mean, this
Correct.
is incredibly powerful.
Right. Yeah, I kind of glossed over the surface, and I know some of it, for somebody that hasn't had some experience in OPC world, it might be kind of confusing to understand what that picture is, and kind of how it fits into the puzzle. And I did have there's one slide here that kind of does talk about this is I didn't want to show this because this has a lot of boxes on it, and it looks fairly complicated. But what this is illustrating is that in an industrial application, you typically have a lot of complexity. You have the plant network that actually has all these devices and stuff running on it. Whether it be supervisory and control stations, like machines around, or workstations around the plant that are used to be able to control pieces of equipment. And then you have the programmable logic controllers I talked about, the PLCs that are actually running the machines. And most companies keep the networks that actually are running this really important and safety critical pieces of equipment separate from the IT network that is used for email and browsing the internet and running line of business applications and that sort of thing. So putting an edge down in this space, in the red space, allows us to actually connect. And actually, there's some some pictures of that on here. It allows us to easily connect to to that data stream and be able to make decisions locally. So I showed the data going up to the cloud, but instead of going all the way up to the cloud, I can actually have like a machine learning model that I've trained in the cloud running on the edge, and actually generating an alert maybe to a plant operator when something happens. So you don't have to go all the way up to the cloud and back to be able to make a decision.
Yeah.
So yeah, it's some really to me, I think this is a cool product. That is ubiquitous. It can run on any type of general purpose compute device. You said Windows,
or
Linux,
spaceships.
Yeah, or spaceships. Yeah, I've got about 300 Raspberry Pis running my weapon system on the Falcon. So, so
The funny thing is that Raspberry Pi is probably more powerful than the things that they would have had available to them in 1977.
that is funny. So my son's really into older computer hardware and looks at all the subreddits on some of the older computer hardware, and there was a compact server, like a DL180, circa 90s era server.
Oh,
and
yeah.
one of the comments was, "My Raspberry Pi on my desk is more powerful than that thing that's making your electric meter spin like crazy.
Yeah, I had a luggable. Remember the compact suitcases?
I remember them. My dad had one of those too. It had a little, I don't even know what size screen that was. Was it probably like a 9-inch monochrome screen, green screen?
Yeah. And then digital. Remember digital computers?
Oh yes, yeah.
Digital actually had a sniffer, and they would essentially take a compact luggable, throw a net card in it, throw some dedicated software in it that replaced the DOS-based OS.
Okay.
And it was a network sniffer, and you could lug it around and plug it into the network, and it would capture network traffic, and it was a dedicated device just for that.
Holy
It was
cow.
crazy because they charged like 2 or 3 times, I think, the price of a standard compact luggable. It was crazy.
And that's all it was just their special sauce put on top of it?
Yeah, it was just a net card and no OS except for their application. Their application acted as the OS, and that was the deal. But man, I can see so many, manufacturing, huge, inventory control, huge.
Yeah, and like I said, I've got industrial customers running these on vehicles. I mean, you can do some really,
I mean, think about a Tesla, and I mean, it's pretty much already an Internet of Things device, right?
Yes.
I mean, it's just crazy, really neat.
Yeah. So hopefully it's this provided kind of some insight. And I just talk on the OPC stuff of the OLE for process control stuff for being able to do industrial communication. But I can build a Python application and tell the IoT hub to deploy that Python application on all thousands of my edge devices running around the globe. And so it actually is a really powerful DevOps story too, to be able to make it easy to deploy updates to equipment you've got around the globe. Yeah.
All right. Well, man, listen. Is there any place people can go to get more information?
Yeah. So obviously at Azure.com, but I will. I'll pass the link. Azure Industry OT. I spelled it wrong, but yeah. So this is actually exactly what I just showed, and kind of talks about how to install this and configure this. So we'll make sure we get the link in the notes.
Okay. Well, I've got to get back to work.
Yeah, me too. Yeah, this.
So, thanks, man.
Yeah, no problem. Thank you.
Oops, it's not working. Hang on. Oh, there I am. Hold on. Oh, where am I? My head disappeared.
That is funny.
Guys, if you can still hear me, that's
yes, I can.
Premiere.
Yeah. Nice. That's awesome. Oh, I think you might be muted. Yeah, I think your mic's not working.
Hang on, I'm going to redo.
There you go. Yep, you're in now.
All right. Well, Bud, thanks. That was awesome. I really appreciate your time. I've got to get back to work now.
Yeah, me too. All right. We'll talk to you later, man. Is that like a legit problem? Where'd you pick that up at?
All right, guys, that's your taste of Premiere. I'm your father.